So in front of us, we can see that we are moving on to conic sections, which is the resulting set of shapes that occur when you take a cone or a double napped cone, which is a fancy way of saying two cones that are placed tip to tip. So the intersection of a cone or a double napped cone with a plane, with a flat surface. And so in front of us, we can see four different types of cross sections that we can end up with. The first one that we'll be taking a look at is a circle. So you can see if the plane intersecting a cone is perpendicular to the height of the cone, then you end up with a circle as the shape that gets generated. We can kind of think about like a sugar cone in an ice cream shop. So you have a cone type shape, and then up at the top where the cone has been sliced, you have a circle. In the second diagram there, if we kind of tilt the angle of the plane, so think of like a waffle cone, now you no longer have a circle as the cross section, but you have an elongated shape called an ellipse. We can also end up with a parabola. So you can see if the plane is parallel to the sides of the cone, you end up with a single U shape. And so we've studied parabolas in a different context. We will study them again in this context with conic sections eventually. And the last one that we see in the set of diagrams is called a hyperbola. So now this is where the plane is parallel to the height. And so it will slice through both the top and the bottom cones. And so you end up with these two separate branches called a hyperbola. But for our purpose, we're going to be taking a look at circles to start off with. And so this is the simplest type of conic section. You've studied this equation before in geometry, so this should hopefully be a review. But our perspective on how we're defining a circle or any of these shapes is going to be a little bit different than perhaps how we've discussed other types of graphs before. For each conic section, we have a rule written in words that then gets translated into an equation. And so in the case of a circle, the written rule is that a circle consists of all of the points that are equidistant, so meaning the same distance away from a single point called the center. And so on the surface of our circle, on the circumference of our circle, are all the points xy. So going all the way around the circle, those are represented by the variables x and y in our equation. And so then the center point is at this location hk, and so we can see that that location shows up in our equation. So we have x minus h, so x minus the x coordinate of the center squared plus y minus k, the y coordinate of the center squared, equals, and so that distance from the center to all the points that are actually on the circumference of the circle is r, and so in the equation it shows up as r squared. And so really all this is just a variation of the distance formula. Normally with the distance formula, we know the 2 points and we're trying to find the distance. In this case, we know one of the points, we know what the radius is, and so then the other point, the second point, this point xy, could be anywhere along the circumference of the circle because that will maintain that constant distance. So this is the equation that we can use to describe a circle on the coordinate plane. So in the equation that we see in front of us, we want to graph it. So we first have to identify what's the center. We then have to identify what is the radius. And then we just plot a few points on the graph and we can sketch it. So notice that in the equation it's x minus h. So when it says x minus 4 in this first part of the equation, that means the x coordinate of the center is positive 4. We've seen this sort of thing before where it's the opposite of the positive negative sign that we see inside the parentheses there. For the y coordinate of the center then, y plus 1, well that means that the k value, the y coordinate of the center is going to be negative 1, because when we minus a negative 1 that turns into plus. So on my graph then I can go over 4, I can go up 1, whoops, could try to actually hit the spot correctly there. Over 4 up 1, it's getting close. And so then we've got to identify what the radius is. So over here on the other side of the equation we see that 36, But we need to take note that in the equation, that's the radius squared. So we need to take the square root of that number. And so our radius is going to be 6. So in order to sketch out our circle, I'm going to go left, right, up, and down from this center point 6 units. So to the right and to the left gets me those 2 points. If I go up 1, 2, 3, 4, 5, 6, right about there, and then down 2, 3, 4, 5, 6, right about there. So now I can sketch my circle. So that's how we can use the equation to generate those points. And then if we were to plug in any of the xy coordinates of any of the points that we plotted, or any of the other points that are on the surface of the circle for x and y, they would work in that equation.